Hey, it's Mr. Redstone, and in this video we're talking arithmetic sequences. If you Google this topic, this formula in blue is going to be your first hit. And there's nothing wrong with this formula. It works, but I'm not the biggest fan of it. The value of the nth term is the value of the first term plus the quantity of the term number minus 1 times the common difference. You lose meaning. I prefer this formula y equals mx plus b because you know it and you've seen it. And I can give you 2 points or a table or a graph or an equation, and you can link it all up. An arithmetic sequence is an application of this formula. Look at that example below, 15, 18, 21, and 24. What I'm going to do is treat those numbers like they're the output of a linear function. The output of a linear function whose inputs are the natural numbers. The natural numbers are your counting numbers, 1, 2, 3, 4. Look at that list. What's the third number? 21. So we're going to treat that 3, 21 like it's a coordinate, or 1, 15, or 4, 24. Now we're not going to use x and y for this. I'm going to get away from that. I'm going to be using different letters, but we're going to be coming up with what we call an explicit rule, or an equation relating the term number, which I'll use n for a variable, and the value of the term, a sub n. Now when you start getting good at these, you probably won't need a table, but for a first example, it helps to see it this way. Now as soon as you see this table, immediately you identify what the slope is. Every time the term number goes up by 1, the value of the term is going up by 3. So we're not going to use the word rate of change, we're not going to use slope. In this context, we call it a common difference, and we use the letter D. In this case, it's going to be 3. We can also calculate the Y-intercept, the value when our input is 0. But we don't call it the Y-intercept, we're going to call it the 0 term. In this case, 12. Having these 2 pieces of information is enough to now write the explicit rule. Your output, a sub n, is equal to 3 times your input, which is n, plus 12. And that's it. That is the explicit rule for the sequence 15, 18, 21, and 24. Next example. Eventually. There it is. So find the explicit rule for the sequence, -5, -11, -17, -23. And then we're going to use that to come up with the value of the 100th term. Just like before, I'm going to write it as a table, our term number and the value of the term. So the first term has a value of -5. The second term has a value of -11. Third term has a value of -17, and the the value of the fourth term is -23. Eventually, probably by now even, you could do these rules without resorting to a table of values. So our common difference is -6. Every time the term goes up by 1, the value goes down by 6. Using that, we can work backwards to find the 0 term. In this case, it's 1. So our rule would be a sub n, or the value of any term, is going to be -6 times the term number plus 1. Now we're going to use that explicit rule to find the value of the 100th term. To do that, we replace n with 100. So -6 times 100 plus 1 would be 599 negative. So the 100th term is -599. Next example. A sub 1 is 20, meaning the value of the first term is 20. A sub 5 is 36, or the fifth term is a value of 36. Use this information to find the explicit rule and find the value of the 33rd term. Okay. What I'm going to do is write out the first 5 terms of the sequence and put in what I know. The first term is 20, the fifth term is 36. Now to get from 20 to 36, we need to know how many common differences did we have to jump? 1, 2, 3, and 4. So to get from the first to the fifth term, we had 4 common differences. And to go from the number 20 to 36, there was a change of 16. So 16 divided by 4 is 4. So our common difference is 4. And now that we have the 5 numbers, it's easy to come up with your common difference, and it's easy to come up with your 0 term. If you didn't want to go to the trouble of writing these 5 numbers out, you could have just realized that we have 1 comma 20 and 536 and treat it like we would have 2 points, find the line. So the value of our 0 term is 16. And that's enough information to find the rule. A sub n is equal to 4n plus 16. And now we can use this rule to find the value of any term we want. In this case, the 33rd term. 4 times 33 plus 16. That's going to equal 148. Next up, a recursive rule. And these students don't like them very much at first, but then they really do like them because they're very intuitive. I like to think a recursive rule models mathematically how our brain interprets a pattern. What do I mean? We see a 12, a 14, a 16, and an 18. I don't know how your brain works, but I realize that I'm adding 2 to the previous number. So if I want the 5th number in the sequence, I need to add 2 to the number before it. So 20, then 22. So the 5th number, or the value of the 5th term, is equal to the value of the 4th term plus 2. The value of the 6th term would have been the value of the 5th term plus 2. The value of the 7th term would have been the value of the 6th term plus 2. So let's generalize this now. What is the value of the nth term? It's going to be the value of the term before it, and subtract 1 plus 2. Now there's one more piece of information you're going to need. You need to know where the sequence started, because there are a lot of sequences out there that are separated by the number 2. There's an infinite number of them. So we need to tell the person reading our answer where our sequence begins. And most sequences will usually indicate the first term. It doesn't really matter which one you indicate, it's just easier if you give the reader the first number in the sequence. So A1 is 12. The next number is found by adding 2. So on and so forth, we can replicate the sequence that was presented. Next up, what is the recursive rule for the sequence negative 2n plus 3? Well, to do this, let's create a table of values. The term number, n, and the value of the term, a sub n. And again, if you can do this without a table, great. So the first term, if I replaced n with 1, the first term is going to equal 1. The second term would be negative 2 times 2 plus 3 is negative 1. The third term would be negative 2 times 3 plus 3, which is negative 3. Now, our sequence is 1, negative 1, negative 3. How am I going from one number to the next? What is that common difference? It's negative 2. And you might have spotted that from the rule initially. But if you didn't, writing the numbers out in a table is fine. So if we want to write this as a recursive rule, what we do is we take the previous number and subtract 2. And then we have to tell the reader where our sequence starts. The value of the first term was 1. That's it for this video. Thanks for watching.